You've seen the headlines, right? Coffee drinkers have a lower risk of heart disease. But what does that actually mean? Like, how do scientists even figure that out? Well, today we're going to pull back the curtain on one of the key tools they use to connect the dots. So one of the main ways they do this is with something called a cohort study. Sounds fancy, but the idea is pretty simple. You take two big groups of people, right, and you follow them for a long, long time. One group does the thing you're studying, say they drink coffee every single day. The other group doesn't. Then years later, you check in and see what happened. But here's the million-dollar question. How do you take all that data and boil it down to one single number that tells you if there's a real link? That's what we're getting into. Actually, you know what? Let's turn this into a little pop quiz. I'm going to hit you with a question that an epidemiologist, that's a public health researcher, would totally know. Let's see how you do. Your job is to pick the right tool for the job. Okay, here we go. The options are relative risk, odds ratio, case fatality rate, incidence rate, and prevalence ratio. Whoa, okay, they all sound super legit, don't they? But only one of them is the go-to for these kinds of studies that look forward in time. Go on, take a second. What's your gut say? Lock it in. All right, pencils down. Got your answer? I know, there are a few tricky ones in there, but there's only one that's really the gold standard for cohort studies. Let's see how you did. The correct answer is A, relative risk. If you got that, give yourself a pat on the back. Seriously, well done. And if you didn't, no worries at all, because we're about to dig into what it means and, just as important, why the other ones aren't the right fit. So we've got the name relative risk. You'll often see it written as just RR. But what is it really? Let's dive into the definition to see what this number is actually telling us. Okay, so here's the breakdown. It's a way to compare the risk in two different groups. Let's make this real. Imagine your exposed individuals are people who smoke, and the non-exposed are non-smokers. The outcome we're looking at is, say, getting lung cancer. Relative risk directly compares the chances of a smoker getting cancer versus a non-smoker. So if the relative risk is 2, it literally means smokers are twice as likely to get lung cancer. It's a really powerful, direct comparison. And you know, a great way to understand why relative risk is the right answer is to look at why the others aren't. Think of it like a toolbox. You wouldn't use a hammer to saw a piece of wood, right? Same thing in statistics. Every tool has its specific job. Let's see what the other tools are for. Okay, first up, the odds ratio. This one is super common, but it's the star player in a totally different kind of game, a case control study. That's where researchers start with people who already have the disease and then look backward in time to figure out what they were exposed to. Relative risk is for cohort studies, where you start with the exposure and look forward to see what happens. It's a completely different direction of thinking. All right, how about case fatality rate? This one sounds serious, and it is, but it answers a different question. It tells you once someone has a disease, how likely are they to die from it? It's all about the severity of the illness. It doesn't tell you a thing about what your risk was of getting that disease in the first place, which is exactly what relative risk is for. Then there's incidence rate. This one's basically a head count. It tells us how many new cases of something are popping up in a population over, say, a year. It's super important for tracking trends, for sure, but it doesn't compare the risk between one group and another. Relative risk is all about that head-to-head comparison, the exposed group versus the unexposed group. And finally, prevalence ratio. This one's for what we call cross-sectional studies. The best way to think about it is like taking a single photograph of a population at one specific moment. It tells you who has a disease right now. But relative risk needs time. You have to follow people over the years to see how things change. So if prevalence ratio is a snapshot, relative risk is the whole movie. Okay, so that was a lot of different statistical terms, I know. To make sure this all clicks into place, let's pull everything together into one simple chart. Think of this as our epidemiologist's toolkit, all laid out so we can see which tool to use and when. And there you have it. This table really lays it all out. Relative risk, that's our hero for cohort studies. Odds ratio is for looking backward in case control studies. Prevalence ratio is for that snapshot in time. And the others, incidence and case fatality, they're answering totally different questions about how many and how deadly. Knowing this stuff is so important because it helps you see past the headlines. You can understand how scientists got their results, and that's the key to really knowing what they're talking about. So from now on, when you see that next big health headline, you're going to see it differently. You'll have this little toolkit in the back of your mind. You can ask yourself, I wonder what kind of study this was. Are they talking about relative risk? It's a total game changer. It puts you in the driver's seat and makes you a much smarter, more critical consumer of science. And that's a superpower.